What up, YouTube, man? I'm back at it again. It's your boy Vest, man, at Unscripted X. Today, I really wanted to work out a number of fractional problems showing how to add fractions, how to subtract fractions. These are problems that typically appears in the ASVAB, and I mean, even beyond the ASVAB, I mean, this is something that is basic knowledge, and you should know. If you're even doing ACT, in various exams when it comes to math, arithmetic, reasoning, or mathematic knowledge, knowing how to add fractions, knowing how to subtract fractions, knowing how to multiply fractions, or even divide fractions, is always a great help, man. And there are ways to work it out, shortcuts to it, so that you don't have to do any kind of tedious work. And so that's what the focus for this video would be. And so without much ado, I'm gonna jump right into it. So let's do, for our first example, let's do, say you're given 2 and then you got 2/3 plus say 5 and 1/3. How do you add this, right? Typically, the best approach to go about this, well, this actually, as it turns out, the fractions for this one have the same base, and so this one probably be simple. It'll be simple to just add the. This is a simple scenario, I guess I should say. As it works out, you can add the whole numbers and then add the fractions. So we add the whole numbers, we get 5. And then the fractions, because they have the same base, right, we can add them together, right? And in this case, we add 2/3 plus 1/3. That should give us about a whole, right? It should be 3/3, which is 1. And so that really converts this from 5 to 6, right? And that's 6. That's a weird 6. Let's change it. So now let's actually test this. Let's convert this to proper fractions. I mean, this is written as improper fractions, right? Let's convert this to proper fractions and then add it to see if we get the same thing. And so for this one, we can take this to multiply it by 3. 2 times 3 would give us 6. And then 6 plus 2 would give us 8. And so we get 8. And then we put it divided by 3. This is our fraction. And then we take this whole number 3, multiply it by this other 3, which would be 9, and then add the 1 that we have up top here. So this would be 10, and so we get what? We get 10 divided by 3, and then we can add, because they have the same base, again, because they have the same base, we can add these two together. And so we add these two together, we get about 18 divided by 3, right? 18 divided by 3, we know, is 6. And so again, you see that these two work out, right? So this is kind of like a simple situation that just happened to work out very well for our case here. Now, what if you're adding fractions that don't have the same base, or subtracting fractions that don't have the same base? Now what do you do, right? That's when knowing how to convert from improper fractions to proper fractions is really going to help out. And so you look at this. Actually, let me use the color blue. Let's take this example. For instance, we have, let's do 5/7, right? And then let's do plus 5, and then let's do the 2/3 again. So here you can see that the fractional parts of it don't have the same base, and so we can't use the same approach here. The same approach that we used before, where we just took this, we added the whole numbers together, and then afterwards added the fractions together. This doesn't work here because these two fractions here don't have the same base, right? So that doesn't work. We can't just add we could, basically we could technically add the whole numbers together, because that would work, but we couldn't. I guess another way to deal with this. Okay, so as I'm explaining this, I've actually thought of another way, right? So we could technically add these whole numbers. So let's actually work it out. So we have 2 ways to showing how to do this, right? So the 7 plus 5 we'll get 12. And then because they don't have the same basis, we can't add them, we can't just add them straight up. And so we can handle the fractional part of it separately. So we'll take this fraction, the 5/7 plus, we'll handle the fractional part of it separately, right? So which is the 2/3. Now, mind you, these fractions have different bases. And so now we need to handle these bases. So to do that, because 3 doesn't go into 7 and 7 doesn't go into 3, we'll just have to multiply these two bases together, right? And so we do that. We get 5 times this same thing will equal 5 times 3 would be 15. And then 5 times 7 times 3 would be 21. So now our base becomes 21, right? And then plus, we do the same thing here. We just do cross multiplication. That's what we just did, right? We took this 3, the base, and then multiplied by 5. And then we also multiplied it by 7. Now we have to do the same thing for the 7, right? We also take this 7 here. We multiply it by 2. And then we also multiply it by 3, right? And when we do that, we're going to get 14 and then over 21. So mind you, now they have the same base. And so now we can add them together, right? And when we do that, we just take the 15 and add it to 14, which will give us 29. And 29 over, because they have the same base, we just keep it at 21. And so that is what this will be. We get the 12, and then the fractional component of it will be the 29 over the 21. So this would be our answer for this one, right? Another way to do this would just be to convert the whole fractions into the whole improper fractions into proper fractions in order to be able to do this. And so to do that, we just take the 7. 7 times 7 will be 49. And then 49 plus 5 would be 54. And so we get 54 divided by 7. And then we do plus. And then we go here, we do 5 times 3 would be 15 plus 2 would be 17. And then this would be over 3. And then again, you'll notice that even though we've converted this into proper fractions, they still have the same. I mean, they still have different bases, right? 7 and 3 are not the same, and so we have to work that out. And we take the we'll multiply the 3 by 7 and 3 by 54. I know 3 by 54 would be what, 150 plus 12, and so it'll be 162. Yep, 162 over 21. I mean, 7 times 3 would just be 21. And plus, and then we do the same thing, right? Where we take this 7 here, multiply by 17, and then multiply by 3. We already know the denominator is going to be 21 because 7 times 3 is the same thing that we're dealing with. But 7 times 17 will be 119. And then now that we have the same base, we can add them together. And so we add the 162 and 119 together. We should get about 281. 281 divided by 21. And so to prove that these two answers are the same, we can convert this to proper fractions, right? So we take this 12 and multiply it by 21. We get 252, and then we add the 29, which gives us 281. And then this is also over 21, right? And so you see that these two answers are equal. One is in improper fraction and one is in proper fraction. So these are equal. So that's just, for dealing with additions, right? So fractional additions, that's just what this example is. Now let's deal with, say, maybe, I think subtraction and addition are very similar. And so I'll probably just do one example of subtraction, and then we'll move on to maybe multiplication or division of fractions. And so let's handle one case of fractional subtraction. So let's do, for fractional, let's do a simple case. Simple case would be like 5 over 7 minus, say, 2 over 7. The simple case is when you have them and they have the same base. In that case, then that's a really simple case. If they have the same base, you can just subtract them through. You don't have to do any additional math. And so we just subtract this through. We should get about 3/7, right? But what if they don't have the same base? That's always the question. Say we had 3 over 8 minus 1/9. Then how do you handle that? Again, you just want to make sure that these have the same basis. When they have the same base, that's when you can carry out the operation that you're being tasked to do. And so in this case, they don't have the same denominator yet. And so what we do is we take this 9, multiply it by 3. We take this 9 and then multiply it by 8. So 9 times 3 is 27. And then 9 times 8 is 72. So now they should have the same base, right? So minus, and then we do the same thing for this as well. We take the 8, multiply it by 1, and then 8 times that. So the base, as before, would be 72. And then 8 times 1 would just be 8. And so now we can actually carry out, because now they have the same base, right? We got 72. Now we can actually carry out the operation, the subtraction operation. And we do that, we should get about, I think, 19 here. So it'll be 19 over 72. Yep. So that's another simple case. But what if you have an improper fraction subtracting themselves, right? So let's handle that case before we move on to the division and multiplication piece of the fractions. So let's assume we had like 2. Let's use a simple case, right? 2, 1, maybe 1/5 minus 1. 1, let's do 2/3. We want to use simple cases here. We're just trying to prove a point. So how do you do something like this? You could try to. My approach to these were always to convert this to proper fractions before actually doing the math, because we could subtract the whole numbers, but we also notice that this fraction is bigger than this fraction, and so if we subtract this from this, we'll get a negative number, and so that might make the math slightly harder than it should be. And so to make the whole process easier on ourselves, we'll just convert everything into proper fractions before actually carrying out the subtraction operation. And so in this case, to convert this into proper fractions, we just take this 2, multiply by 5, and then add 1. So that'll be 10 added, the 1 added, it'll be what? 11. So that's the conversion from improper to proper fraction for this first scenario. And then we do the same. We take this 1, multiply by 3, and then we add the 2. So 3, it'll be 5. And then divided by 3. But so now that we've converted these two into proper fractions, you will notice that they still do not have the same base. And so we cannot carry out the subtraction operation, right? Before we can carry out the subtraction, we need to have the same base. And so that's what we need to focus on next. And the way we do that is we take this 3, again, multiply by 11, and then multiply it by 5. We do that. We should get, so 11 times 3 would be 33. And 5 times 3 would be 15. And we do the same thing for this side, right? We do the 5 times 5 and 5 times 3. We already know the 5 times 3. We've already done that. So we could just carry that value here. And 5 times 5 is 25. So now that we have the same base, we can do the subtraction or carry out the subtraction operation. And so in this case, then we take 25 from 33. That should equal 8. So 8 over 15. So this would be our answer for that one. So typically that's how I handle these. So let's now jump on to multiplication, and afterwards we'll do the division, and we can end there. So yeah, with multiplication, I think handling multiplication, fractional multiplication, is probably the easiest. For instance, we have 2/3. 2/3 times, say, 3/5. This is just multiplication, and so we don't really care if they have the same denominators or not. We don't really. We just take we multiply the numerator by the numerator, the denominator by the denominator, and that should give us the correct answer. And so in this case, then it'd be 2 times 6 would be 6, and 3 times 5 would be 15. So the multiplication, fractional multiplications are pretty easy. But what if you have an improper, say you have 2 1/3 times, say, 5 2/5, right? What I haven't tried before is, well, let me see if this actually works. Maybe we could multiply the whole numbers together. You multiply the whole numbers, you should get about 10. And then now we can multiply the fractions, right? You multiply 1 times 2, that gives you 2. And 3 times 5, that gives you 15. So that's what we get. But let's also do it the proper fraction way and see what we get. Proper fraction way, we take this 2 multiplied by 3, that gives us a 6, and then plus the 1, so that'd be a 7. Divided by 3, because 3 here is the base, and multiply that by the 5 times 5 will be 25, plus the 2 here, so it'll be 27, divided by 5. So once we have it this way, we could just carry this whole thing out. We know that 3 times 5 would just be 15. So really the one we need to do is a 7 times 27. Which gives us 189. 189. So now I'm curious. I want to convert this into a proper fraction to see what it equal to see if we get the same answer. So we take this 10, multiply by 15, we get 150, and give me a second here. We get 150 and plus 2, so plus 2, we get 15. So yeah, I guess that this way doesn't work. Yeah, I'm pretty sure this way doesn't work. But in any case, I'm pretty sure this would be the case that works. But let's test it. Let's test it. Let me pop out a calculator. Okay. And then we could do 2.33 times 5.2. 5.2, and it'll be 5.4 actually. And then we get 12. Yes, we get 12.59, blah, blah, blah. Which is what we should get when we divide the 189 by 15. Should give us, yep. So this, when we divide this by this, we should get about 12. 3.6, which is roughly what the calculator showed. And so, yeah, that was just to prove a point. You can't do it that way, this way. You can't take the whole numbers, multiply the whole numbers, and try to handle the fractions and then try to add them together. That doesn't work. So with fractional multiplications, what you want to do if you get improper fractions is to convert it to proper fractions like we did here first, before carrying out the multiplication operation. So hopefully that point is made clear. We when we did this value doesn't equal what we should get, which is about that 12 point something. So this doesn't work. This works. So now that we've done multiplication, let's move on to division. So with division, typically the divisions also become we can turn divisional problems into multiplication problems. And so say we had 3 over 5 divided by 2/3, right? No one wants to actually sit there and try to do long divisions on these two fractions. I mean, you know how tedious that'll be. And so typically the way we work this out is we flip the fraction in the denominator, right? This fraction here. We flip it around, or we use its reciprocal. And so instead of actually doing a fractional division, we just do a fractional multiplication because we flip the denominator around. So when we flip the denominator around, this now becomes 3 over 2. When we do that, now we can actually do a multiplication. So we convert the fractional the fractional division into a fractional multiplication. And so once we turn it this way, we can just carry out multiplication. 3 times 3 is 9, and then 5 times 2 would be 10. And this would give us the answer. So yeah, I mean, as you would imagine. Now the question is, what if you're given, improper fractions? So 3 divided by, say, let me see. Divided by, let's just do something like this. Divided by maybe 1/5. How do you do something like this? Again, because of the math we did, that didn't work. You can't just take out the whole numbers and try to do something like this. The best then would be to convert this into a proper fraction first, and then carry out the multiplication or the division operation. And so in this case, then we convert this into proper fraction. 2 times 3 will be 6, plus 2 will be 8. And so this will be 8 over 3. Divided by, and then we take the 3 times 5 will be 15, and then add the 1 here in the numerator. And so this will be 16 over 5. So now that we've converted into proper fractions, we can do the reciprocal thing, right? Which is just flip this around, and so this really becomes 8 over 3. Let me actually put a bit down here. A line. 8 over 3 times 5 over 16. We flip the denominator, the fraction in the denominator, to its reciprocal. And so we do that. Now we can carry out the multiplication. We just be 8 times 5, which will be 40. And 16 times 3, which will be 48. And this will be the answer for this one. So yes, this is how you handle fractions. I know this was specifically requested by one of my viewers. Hopefully this makes sense. If it doesn't, let me know which parts you may have gaps in, and I'll try to go a bit more in detail. But I hope this helps, and until next time, I mean, if you like this video, I should say, like, subscribe, and leave a comment. Let me know what you like. Let me know what you don't like, or maybe what areas could use improvement. And if this helps you out, maybe you want an exam or something, do make sure to leave it in a comment. I do enjoy making these videos for you guys, and I'm gonna keep making them. I do have plans to make a lot more videos, maybe even branch out to other areas like the ACT, SAT. I did make some SAT, ACT videos in the past. That didn't catch too much traction, but I'll probably jump back into it and do other learning tutorials as well. So if you like these sort of videos, do make sure to let me know, and I'll keep them coming. Thank you for watching, and I'll see you next time. Bye.